Hi friends, my name is Ash Bissoy from grade 8 and here I have brought you a physics chapter which is the first physics chapter of the grade and the chapter 11 of the science textbook, that is force and pressure. So before we get into chapter we have to learn again some very important terms, and these terms will summarize the most part of the chapter, and these terms are force, Newton, pressure and Pascal. So what is force? We have been learning force from grade 4 since grade 4, and this most simplest definition of force is the push or pull. So force is the push or a pull on any type of object. And what is Newton? Newton defines how much force. So Newton is the measurement of how much force is being exerted on the object. So now, what is pressure? Pressure is a very new. The definition is very new, but pressure is a common word being used from earlier grades. What is pressure? Pressure is the force acting on an object, that is acting on an area. So pressure means force acting upon an area. And what is Pascal? Pascal is the unit or the measurement of how much pressure. Pascal is denoted by Pa, and Newton is denoted by N. What is N by M2? N by N2 means N means force and M2 means area, as we have seen here. So either we can write Pa Pascal or Newton upon meter square. Okay, now we'll be learning force and Newton in more described way. So force. When does force occur? Force occurs when there is an interaction. Interaction. So when two objects are in interaction, like when they pull, they are in an interaction, or even when they push, they are in an interaction. So for always for a force to act, an interaction is necessary. Now we learn Newton. Newton is the measurement of the force. I will give you an example. This is a box. A person is putting a force of 10 newtons. So what is 10 newtons? So 10 newtons is the amount of force exerted by the person on the box to move it. So in every scenario or every action that we do in our life, in our daily life, everything is a force. Our heart beating is a force. Our movement of our hands is a force. That's muscular force. When we play sports like cricket, football, even that includes sports. So everything in the world requires force, because work has to be can only be completed when force is acting. Okay, now we will be going into the effects of force. Okay, so before we go into the effects of force, we will learn two types of forces, or the types of forces which act. One is a balanced force and another is unbalanced force. I will show an example of balanced and unbalanced. Take this box and take this box. When here is a 10 newton, and from this side take it 6 newtons. So here it's not a balanced force. You can see that from one side the amount of force acting is too much. In this case it's not equal. 6 and 10 are not equal. But in case of here now, we will take 8 newtons and 8 newtons. Here this is a case of balanced force. Here 8 newtons and 8 newtons equalize each other, and that's why this is called a balanced force. Now you have to keep these two things in mind, and we'll be learning the effects now. Okay, effects. The first effect is force changes motion. Now, the ball, this is a ball, and this is going in an direction and has 3 newtons. Now you are also standing here and you also kick this ball by 7 newtons. So what happens? The force increases now. So now the motion was slow, but after you add the 7 newtons by yourself, the motion increases and the speed also increases, and there are chances that sometimes the direction can also change. If you are putting the direction in another from other direction, then the ball can even change its direction. So that means force changes the motion. Now we'll be going to the next. And when this motion changes, when there's an unbalanced force. So when one side has a greater amount of force and another has a lesser amount of force, that's why the greater amount of force pushes the pushes more power, and because of that, the motion changes, or the motion comes into the play and the object moves. Now we'll be looking the other effect. It changes shape and size. Now you would have noticed in your house when two people are fighting and pulling for a shirt, the shirt tears. In this case, the shape gets altered or the shape gets distorted. So this is an example of balanced force. Now you are putting a pressure of, take, 5 newtons, and from this side also 5 newtons. So because of this, this and this walls of the box contract and there's a change in the shape. Now this happens because of balanced forces. So shape gets changed because of balanced forces. Balanced forces. So these are the two effects of force. One is the changes in motion because of unbalanced force, as I told, because if one side has a lesser amount of force and the other has greater, so the greater amount will push and have an increase. It has an extra 4 newtons in now if one has 6 newtons and has 10 newtons, so 10 newtons has extra 4 newtons in comparison to the other 6 newtons, because of which this 4 newtons is gonna push the object. And in the case of changing a shape, the two forces are equal, so there is no change in the motion but there's change in the shape. Okay, now we will going to the next part, that is the calculations required during forces, how forces act in the same direction, and what is actually force, and what are the two things that force has. Okay, so before we learn this, we have to know something, that force has is a vector quantity. It's vector. What does vector means? Vector means it has a magnitude. Magnitude means strength. Magnitude, that means strength. And it has direction. It has direction too. So force is a vector quantity. It has a magnitude, that is the strength, as we said Newton. Newton is a unit which measures the strength of the force. Just like that, because of that, force is a vector quantity. Vector quantity means any type of quantity which has a magnitude as well as a direction. That means the strength is moving in a direction. Okay. Now we will be seeing the two scenarios. You will be seeing two conditions here. So just think this box. This box. You are putting a pressure here of 8 newtons. And even your friend is putting a pressure here of 6 newtons. What is it gonna be now? That now the total force is gonna become, it will become 14 newtons. Why is it? Because whenever two forces are acting in the same direction, the forces get added. In here, the two forces acting are going into the right hand side. Because of this, the 8 Newton and 6 Newton get added up and it becomes 14 Newton. Now, in the other case, you take here 8 Newtons and here 6 newtons. So where is it gonna move? It's gonna move this side. Why? Because 8 is greater than 6 newtons and the force is acting to the right side, so it will go right side. By how much force? 2 newtons. So that means whenever two forces are acting in the opposite direction, in the opposite direction, then their forces will get minused or they'll get subtracted. Here it was 8 newtons from the right hand side and 6 newtons going to the left hand side. Because of this, 8 minus 6, it becomes 2 newtons. So it's 2 newtons to the right hand side. So this is clearly evident that how forces act on an object. And what is magnitude? This 8 newton is the magnitude. This 14 newton, whatever force is acting is the magnitude here. Okay, now we'll be going into the types of force. So now in the types of force, there are two types of force: contact force and non-contact force. So in contact force, there are two types of forces given in the book. The first one is friction, and the another one is muscular. So now let's learn first the contact forces. What is friction? Friction, anyway, is going to be the next chapter, the chapter 12. So now we'll be learning a brief about friction. What is friction? When two objects come in contact with each other, they rub each other, and because of that, a force is acting. When you walk on any surface, it's the friction, the rub between your shoes and the ground, which is making your speed a bit more slow, and because of the friction you are able to walk on the ground or else you can slip. Because so friction is a force acting between two objects when they rub each other. What is muscular force? Muscular force is any type of force that works on our muscle, or the type of force that is exerted by our muscles, like lifting a thing, pushing a ball. Every type of work that we do is from our muscular force. When we cut things, when we lift, now I'm lifting this pen, so that's because of the muscular power. Now we'll go into non-contact force. First one is electrostatic. Electrostatic. What is electrostatic? Electrostatic means there are two types of charges. One is the positive charge and one is the negative charge. So when these charges come close to each other, they can either attract each other or repel each other. So for this there are three scenarios. When there's a positive and a negative, they attract each other. They attract each other. They attract each other. is an attraction. Attract. When there is two, when there is two of the same type of charges, like two negative charge or two positive charge, they tend to repel. Same here. And what is the other scenario? When there is no charge and there is a minus charge, or no charge and a positive charge. In this case also there is an attraction. So here we can see that there are different conditions on which two objects will either interact or they'll attract or repel each other. So electrostatic has an attractive and a repulsive nature. Now we'll be seeing the next, that is magnetic. The magnetic force. You can see that in contact forces, two things have to come in contact for the force to work. For muscular, how we hold the thing to make a force, like that, even friction, we need to make contact with the ground. But in case of non-contact force, you can see that there is no need of an interaction or any type of contact between the positive and negative to for the force to occur. Even if they are far from each other, still they can work. Now, magnets we have learned from our lower classes. Now, this is a magnet. The same thing of electrostatic force even works here. The positive and negative attract each other, whereas the of the same poles repel each other. So only the thing is that there are substances of other charges in electrostatic force, whereas in magnetic there are magnets, and they also have the same thing. They have a positive end and a negative end, and even they repel and attract the same way how electrostatic force do. And now we're going to the gravitational force. Gravitational force. So we know what is gravity. Gravity is the magnetic pull by the Earth's core which keeps everything on the ground and we don't fly away. So gravity is any type of attraction by any object in the world which attracts, like how our Earth. So Earth pulls us, and this pull is known as the gravitational pull. And even for this, there is no need of the contact. The magnet is 1,000 times far from us, but still its force is so much that it can keep every object on the world on the ground. So now we'll be going into pressure. So, pressure. I have already told you what is pressure. Pressure means the force acting on an area. Now I'll show you how is that. Take this side of the box, this side, and we are putting a pressure of 10 newtons. So, this side, think that this side is 5 meters. So 5 meters square, sorry. So what will be the pressure? As we know, it is force upon area equals to pressure. So it will be 10 newtons upon 5 meters square. That is 10, that is 2. So 10 divided by 5, 2. So it will be 2 Pascal. We can write Pascal, or we can write the unit, we can write 2 N upon meter square. N upon meter square is also written as Pascal, PA. So now you would have understood what is pressure. Pressure depends on the force and upon the area on which it is acting. Now we'll take another example. This is a table. Yeah, this table is 6 meters square, and the force you are putting some books, and the force is 30 newtons. So how much is gonna be the pressure? Pressure will be 30 upon 6, that is 5 pascal. 5 pascals. Okay, so this is what pressure is. Now we will be going into, does liquid and air also exit pressure? We will be seeing that. What do you think? Do liquids exit pressure? That means, do liquids put force? Let's see through an example. Now take a bottle and you fill it with water. What do you think? Where does, if they exert pressure, where do they exert the pressure? They exert the pressure on this part. They exert the pressure on the walls of the container. So wherever the water are containable, that means they have to be kept in an object. That's why wherever they are kept, they exert the pressure on that object or the walls of that container. So now we'll see that how, if they exert pressure, how do they exert pressure? We'll take an example of bottle, and then we fill it with water. So pressure means the force means the weight. Now at this point, if we take this point, at this point the force is very minimal. Why is it minimal? Because there is no force acting upon it, so that's why the Newton or the force acting on it is very less. That's why the Newton here is very low. The pressure is low here. What about here? Here also it's average, it's just more than the above layer. But why? Because this part puts the pressure, so that's why it's average, as I told. Now what about this? This is medium pressure. This is medium pressure. That because here the force is acting. The two other layers that we saw just above are putting pressure on this part. And what about this part now? This part has the highest or the max pressure. Why? Because all the liquid is putting the pressure on the most depth. So what do we understand from this? We understand from this that as depth increases of the water, the force increases. So this is max and this is minimum. Why? Because this is very deep. So we can here understand that as depth increases, the pressure increases by the liquid. It doesn't, the liquid pressure doesn't depend on the area which one is acting. It depends on the depth it's acting. If there is if the area is large, still the depth and depth will be too much, so the pressure also will be too much. That means liquid pressure doesn't only vary on the area, it varies on the depth too. Now we will understand this a bit more easily. This activity is very common. You make holes. You make a hole here. You make a hole here. And you make a hole here. Now how is the liquid gonna flow? And you fill the water like this. The liquid will come like this, and this. You can see that the first and topmost hole, that is A, B, C. So A doesn't have too much pressure because too much liquid is not above it, and it has the lowest depth. So with lowest depth, the pressure will not be too much, and if the pressure will not be too much, then it will not go a large distance. B goes more distance than A because it has more pressure and more force acting on it. And C sea has is the most deepest, because of which it has the most pressure, and that's why it goes the longest distance because of too much pressure acting on it. What about gases? Even gases exert Even gases exert pressure on the walls of the containers they are inside. Now, when we put any type of gas inside a container, they tend to put a pressure, or they tend to exert a force on the container too. Now, what is the pressure of gases or air called? It's called atmospheric pressure. I don't think there is any need of giving an example for atmospheric pressure, because the most common example that we see is cyclones. Why do cyclones happen? We have learned this last year in grade 7 itself, that a low pressure area, when there is pressure less, the winds move with high speed and causing cyclones. So here high pressure and low pressure come into play. So this is atmospheric pressure. The atmosphere above us is having also weight. That is, gases also have weight. That means even gases put pressure upon us, and we should have been squeezed till now. We would have bursted if there was no blood inside us. The blood inside us acts as the blood pressure. The blood pressure counterattacks the pressure being exerted by air. Because of this, the pressure outside us, that is the atmospheric pressure, and the blood pressure are same. So ATM means blood pressure, atmospheric pressure equals blood pressure. So atmospheric pressure and blood pressure equals each other, because of which we are alive. If atmospheric pressure would have been greater, we would have been squeezed, because there is no other pressure which will keep ourselves inflated. And if blood pressure would be more, then our blood pressure, as we know, that pressure goes from a higher pressure to a lower pressure area. So the pressure inside us was higher, so it would go outside, and if that happens, then we would have bursted. So there is no chance of living if the atmospheric pressure and blood pressures are not equal. That's why when you go in aeroplane, you will feel your ears paining, and sometimes even you can bleed, because the atmospheric pressure is low and the blood pressure is high, because of which the blood tries to come out of our body. Now we will see an example of how much power atmospheric pressure has. Now you have some sucker type of glue. So when you suck and remove, when you keep an object like this on the ground, there is air down and up, because of which you can remove this back. But when you suck it, there is nothing left. When there was air below, so that air could counterattack the air pressure being put above, because of which this was air can be removed. But now this has been removed, this air has been sucked out, so it becomes like this. There is no air, and because of which the pressure increases. So once you suck out the air from anything, it's very hard to take that object back. Now you can't take this back, because the atmospheric pressure, the pressure of air and the layers of so much atmosphere put such a great amount of force that this sucker cannot be removed back. You can see this activity in your textbook too. Now we have to see some proportionalities when we come into pressure. So as we know, pressure equals to, that is force. Force means Newton, and meter square means area. That is, if area decreases, then pressure increases. This is called inversely proportional. That is, if one thing goes, the value of one thing goes down, so the other value will increase. In this case, pressure is up and meter square is down, because of which if meter square decreases, that means the area decreases, then the pressure will increase. See here, 2 Newton. This is sorry, 2 the area is 2, and in Newton that will be 10. So the pressure is gonna be 5. And we can see another example, 10 Newton, same, but this time it's 5 meters square. So what is it gonna be? It's gonna be 2. This means if pressure increases, then the area is going to decrease. That's why you can see knives. Knives have to be kept sharp if you want to cut things, because if it's sharp, then the area is very less, and if area is less, then the pressure is high. Now you have to see the back strips. The back strips are as broad as possible, because if they are as broad as possible, then the pressure acting on them is low. Now, in the case, now if meter square the area increases, then pressure decreases. And as we told, now the last scenario, that is, we will be seeing that if force increases, then even pressure increases. Now how is this possible? This is directly proportional. Why? Because Newton and pressure both are up, that is, they are up of this division symbol. That because of that they are directly proportional, and directly proportional, like the two things will have the same, that is, if one increases then the other will also increase. So this was the chapter force and pressure. I hope you have liked this chapter summary, and if you really liked it, then please click on the like button, and please help your other friends learn this important physics chapter, force and pressure, by helping your friends. And if you haven't subscribed the channel, then please subscribe it and click the bell button to be updated with my upcoming videos and summaries too. Thank you.